All right, guys, this is for my algebra class. You should be watching this, I believe, now on Thursday, September 3rd. Yeah, Thursday, September 3rd. Okay. Today we're going to talk about function notation. So previously, you looked at lines, and you had lines written in this format. Okay, this is slope-intercept form of a linear equation. Okay, specifically, maybe you would have y equals 3x plus 7. And then it would say, they might have given you a table, an x and a y table, and said, fill in this table, 2, 3, 4, etc. Or they might have said, if x equals 1, find the value of y. Or they might just have given you a point and said find, or a part of a point, part of a coordinate, and said find the other portion of that coordinate. Okay, so all of this stuff is done in the past, where you're basically plugging 0 in for x, 3 times 0 is 0, plus 7 is 7, and you should be fairly comfortable knowing that like the y-intercept of this slope-intercept form of equation is 0, 7. Okay, another way that they could have done it is they give you the question, they said if x is 1, find y, so 3 times 1, and then add 7, okay, 3 times 1 is 3, plus 7, y would be equal to 10, okay, or they would just give you a table and say find those values that correspond, so plug 2 in for x, 3 times 2, and then add 7, so 6 plus 7 is 13, okay? Or if it was 3 times 3 is 9, 9 plus 7 is 16, and if you notice, because we're going up by 1 each time, what we should go up by is the slope. We're increasing by that slope of 3, and if you plugged in 4, you would have gotten 19. Etc. So this is how you've looked at lines in the past, and specifically equations. How you're going to look at it now is in function notation. So f of x equals mx plus b. Okay, so that same equation, f of x equals 3x plus 7. This is the same equation we just looked at. Like literally, if you rewind, it's the same function. Okay, it's still a linear function. F of x is interchangeable. I don't actually know if I'm spelling this correctly. Interchangeable with y. It means the same thing as y. It is the function notation way of writing output variable. Okay? Literally, so f of x is interchangeable with y. They mean the same thing. They represent the same thing. No matter if we had it say y equals 3x plus 7, or if we said f of x equals 3x plus 7, both of them translate to output value equals 3 times the input value plus 7. That's literally what they mean, okay? Both sets, okay? The only difference is we have a cool little x there. And the way that we use that x in function notation is it allows us to plug in to our function notation any number we want to for x. And what that does is it tells us to plug that number in for our input over here. And so this statement literally translates to the function. It literally translates to the output value of our function when x equals 0. I'm going to highlight some things. This means is, over here, 3 times 0 plus 7. And why do we use 0? Because that is our input value. So literally this statement, f of 0, that means f of 0, the function using 0 as our input is 3 times 0, because that's our input, plus 7. Okay? And this is what this statement means. And we literally translates to the output value of the function when x is 0 is 3 times 0, because that's the input value, plus 7. If we were to solve this out, that's 0 plus 7, which is just 7. So literally, we had the coordinate 0, 7. We already knew that was an answer. And the way we write that point in function notation is to say f of 0 equals 7. And this is the function notation way of writing our answer. And all it means is our function, when 0 is our input value, is 7. Another way of saying that is the output is 7 when the input is 0. Another way of saying that, if x is 0, y is 7. Okay, because this represents y. All of that f of x represents y. So a function is the output when the input is 0, the output is 7. 0, 7. Okay? I'm not going to create an ed puzzle off of this. I'm just going to have you guys pause the YouTube video and solve stuff in it. So if I had the function f of x equals 3x, sorry, I don't know why I keep doing 3, equals 5x minus 2, I want you to find, okay, f of 3. Press pause right now so that you can stop it and then solve it. Okay, you have hopefully solved it. F of 3 means we are looking for our function 5x minus 2 to be evaluated when x is 3. So all we're doing is solving this side of it. 5 times 3 is 15. 15 minus 2 is 13. So the answer is 13. That means our y value equals 13 when our x was 3. So we could technically write this as the point 3 comma 13, but the way we should write it in function notation, because that's today's lesson is writing stuff in function notation, this right here would be how we would write it in function notation. F of 3 is 13. Once again, this just means here's our x, and this just means here's our y. And that's all it is. Okay? Same function. Let's try a different input value. Okay? Why don't you guys find f of negative 2? Press pause on this YouTube video, solve it, and then check your work when you resume. Okay, you should have unpaused it. You should be back. F of negative 2 is the same thing as 5 times negative 2, because that's our x value, minus 2. Let me close down my email. That way I don't get interrupted anymore. There we go. Okay, so that becomes negative 10 minus 2, or negative 12. So negative 12 is the y value in our coordinate, and the x value would have been negative 2. The way we would write our answer now in function notation, f of negative 2, is negative 12. Okay? Let's try one more. Go ahead and find f of 0. Pause this video, solve it, and then unpause it. Okay, you should be back now. F of 0 just means I take 0 and I plug it in for x. 5 times 0 minus 2 is 0 minus 2, which is negative 2. So we have, in function notation, we can write the statement f of 0 equals negative 2. Here's what that means. I'm repeating myself over and over again, trying to get you to learn it. Here's what that means. x equals 0, y equals -2. Meaning, we have the coordinate 0, -2. But you should already be able to tell, looking at this, that is our y value of our y-intercept anyways. So that should make sense to you. But this is how we write our answer in function notation. Okay? I'm keeping with this same equation, because I can pretty much do all of class using this equation if I want to, or most of class. Right? What if I said find 3 times, that's an ugly 3, let's draw a better one. 3 times f of 2 plus f of -1. So now I'm getting a little bit more complicated. The way I would solve this is I would treat them as two separate ideas and then I would add them at the end. Now we're getting into an algebraic expression. We're going to find 3 times f of 2, then we're going to find f of -1, then we're going to sum them together. But in finding 3 times f of 2, I have to first find what f of 2 is. So let's find f of 2 first. I'm going to show my work here and then I'm going to erase it. F of 2 equals 5 times 2 minus 2. 5 times 2 is 10, minus 2 is 8. So f of 2 equals 8. Keep that in your memory banks. Okay? So now we know what f of 2 is. So 3 times f of 2 is really 3 times 8. Hopefully that makes sense, because if f of 2 is 8, 3 times that is 3 times 8. Now let's look at f of -1. F of -1 is 5 times -1 minus 2. 5 times -1 is -5, minus 2 is -7. So now we have the statement f of -1 is -7. Okay? I'm just showing my work, kind of summarizing my work up there. Right? So plugging that in, f of -1 was just -7. And what are we doing? We are adding these two ideas together. So our final answer will just be 24 plus -7, so that's just subtraction of 7, which is 17. That's our final answer. Hopefully you're with me on that. So I went through a lot really quickly on that. I'm going to have you guys practice that now. Again, the nice thing about this being a YouTube video, you can pause and rewind and rewatch any time. Let's try f of 10 minus, I don't know why I keep having 3's on my mind today. Minus 4 times f of 1. Okay? Go ahead and press pause and try to solve that. Not solve it, but evaluate that. And then unpause it when you're ready, and I will resume teaching this. Okay, you should have unpaused it now. And we are back to solving this. So let's try to find f of 10. F of 10 is going to be 5 times 10 minus 2. So that's 50 minus 2, also known as 48. Okay? 48. So we're just writing that up there. 10 is 48. I've got 48 written right there. Let's find what f of 1 is. Notice I'm just finding what f of 1 is. F of 1 is 5 times 1 minus 2. 5 minus 2, which is 3. So I'll write that up there. It's just a side note. F of 1 is 3. Okay. Again, if I'm going too fast for you, the good news is you can pause it, rewind it, rewatch it, etc. So I've got minus 4 times whatever f of 1 was, which we just identified was 3. Okay, so notice f of 1 is 3. So what I've really got is 48 minus 12, because 4 times 3 is 12. 48 minus 12 is 36. Final answer. Pretty sweet, yeah? Okay. What if I add in a second equation? So I've got f of x is 5x minus 2. And now I'm going to add in a new equation. Since it's a different equation, I'm going to give it a different title, g. This is the f function, and the f function is 5x minus 2. It uses x as the input. Here's our g function, and it also uses x as the input variable. But the title of it is like, this is the g function. That's the name of it. G, the function, using x as the input, is, we'll say negative 3x minus 1. Nah, let's just keep it as negative 3x. No plus or minus, just it is negative 3x. Okay? What I can do is I can say, I want to find f of 3 plus g of 1. Okay? See if you can do that real quick. Go ahead and try to solve that, or evaluate that, and then unpause when you're ready. Okay, you're probably back by now. So I'm going to highlight, this is what we're looking to solve. So first we need to find f of 3, right? That's the first thing we need to find, f of 3. So that's 5 times 3 minus 2. 15 minus 2 is 13. So f of 3 is 13. Hopefully that's not too fast. Again, you can rewatch that if you need to. Right, f of 3 is 13. Let's try this one now. G of 1 is negative 3 times 1, which is just negative 3, right? And it looks like we are adding those together. So if I'm summarizing what that side was, G of 1 we said was negative 3. This is the function notation, function notation. When I'm providing an algebraic expression between multiple functions like this, or multiple operations, I don't really need to write my answer in function notation at the end. I just need to find out and evaluate what that numeric value is. 13 plus negative 3 is 10. Okay. One level more difficult now. Let's go with 2 times f of 1 plus 3 times g of 0. Okay, go ahead and pause this, and then rewatch it. I mean, pause it, solve it, unpause it when you're ready. Maybe you're ready by now. Okay. I want to find f of 1. 5 times 1 minus 2 is going to be 3. Okay? So here I've got 2 times 3, summing up with whatever that is. Because 5 minus 2 is 3. Boom. So here I've got g of 0 is negative 3 times 0, which is just 0. So this becomes 3 times 0. 6 plus 0 is 6. I know I'm flying through it, but it's also a late Friday afternoon right now at the end of a long, long week of pouring my heart out to you kids. And I'm still prepping video lessons for next week so that everything is all prepped, so that if any more calamities and disasters go wrong digitally with programs not working, at least the YouTube links are already there so you guys can learn. So that's why I'm really tired but working hard for you anyways, okay? Boom, boom. Okay, now I'm going to go into the next level. What is the one thing that's been common for all of the problems so far we've done? You ready for it? The one thing that has been common in all of these problems is I've given you the input value of x. Now we're going to switch gears to what if I don't give you the input value? What if I give you the y value? Well, if I give you the y value, the thing that you must then be looking for is the x value. Okay? So, for example, what if I said, hey, y equals 2x plus 3, and then I said, if y equals, I don't know, 11, find what x would equal. Well, how would you solve something like this? Well, you would plug 11 in, not for x anymore. We would not do that. Now we would take 11 and plug it in for y, meaning 11 equals 2x plus 3. Okay? Subtract 3 from each side. 8 equals 2x. Divide it out. X equals 4. And we would be left with the ordered pair coordinate 4, 11. This is something you probably have done in the past. Except, what's different now, and again, if I'm going too fast, pause it. What's different now is we're not using y. We're using function notation. So I would have given you f of x equals this. It's the same thing, okay? Let me make this a better drawing now. You know what, I'm just going to redo that. Okay, and instead of me saying if y equals 11, I'm going to say, what if f of x equals 11? Okay, let me make this very clear. This 11, literally the problem is going to be the same thing. Guess what? We're still going to get the answer of 4. Mind blown, right? Now, take this 11. Don't substitute it right there. That would be wrong. That's what we have been doing when we were subbing in an x value. Don't do that. If we just plug something in right there, that is an x value. That's not what we want to do. We want to take this 11 and plug it in to this entire side of the equation, since this entire side of the equation technically represents y. It's as if it was a y. Okay? So we're going to take that 11, we're going to put it to that entire side of the equation, and what should now be rewritten is 11 equals 2x plus 3, and you're going to notice when you solve this all out, move the 3 over, this is an 8. 2x equals 8. Divide it out, x equals 4. We get the same answer, okay? So, now let's try practicing that. Here's f of x, our same function we had been using. Let's say if f of x equals, I don't know, let me try one off the top of my head, 23. Find what x equals. Pause it and solve. Okay, unpaused now, hopefully. All you're doing is taking 23 and substituting it in for this entire side of the equation. So we have 23 equals 5x minus 2. From there we add 2. You'll notice that we get 25 equals 5x. Divide that out, x equals 5. Boom. Now, how would we write that as a point? Check it out, are you ready? 5 comma 23. How would we write it in function notation? F of the x value, 5, equals 23. And there's our function notation way that we could represent this. Let's try this all again. Find x such that f of x equals 48. Okay, go ahead and solve that, solve that out for x. Okay, press pause if you need to, solve it out. All right, unpaused. All we're doing is taking 48, plugging it in to this entire f of x. So we get 48 equals 5x minus 2. Solving that out, 5x equals 50, x equals 10. Now let's write this in function notation. F of our input, 10, equals our output of 48. And that's how we state that, and that's how we do it. Okay? Now I'm going to show you how most of these problems are worded. So far, the way that I've worded all of these problems is the way that your mind probably thinks about it. So I've worded everything the way that your mind would think about it. Now I'm going to show you how oftentimes it is worded. Oops, sorry. I'm going to group all of this. Okay, so most of the time they're going to give you something like this, and it's going to be written like this and kind of nasty looking. By the way, that's a semicolon. Semicolons separate two thoughts. The first thought is right here. This is our function. The second thought is right here. It's just some value. We don't really know what that value means unless we have some words that goes with it. But right now we know we've got a function and we've got some value. That's all this means when we have a semicolon there, okay? And it's separating two thoughts, our function, some value. It says, find x such that the function is the given value. Or it might not even say the function. It might say such that, ooh, that was not supposed to be, such that f of x is the given value. Now we know what this thought is. We're looking to find x, so we're solving for x. So if we're solving for x, we must be given the y. That's literally all this is. It's as simple as that. If it says find x, you must have been told what the y is. The y must be 28. What this means is find x such that f of x is the given value. So this given value must actually be f of x. Right? What they're basically telling us is f of x is 28, meaning use 28 over here. Meaning set up our equation to be 28 equals 5x minus 2 to solve to get x equals 6. Okay, that's what they mean. And then if they want the answer in function notation, f of 6 equals 28. Does that make sense to everybody? Yeah? Okay. Hopefully everybody's good with that. Let's try another one. I guess I could have just pressed pause on the YouTube video, but now you get to see me put in a little bit of effort and what goes on behind the scenes sometimes as a teacher. 13. Okay, find x such that f of x is the given value. Pause it, solve for x, write it in function notation. You guys ready? Okay, you should be back by now. All we're doing is we're saying 13 equals 5x minus 2. Solve it all out. 15 equals 5x. X equals 3. And guess what? We've been using this equation long enough. I think we've solved for this. And we've got f of 3 equals 13. Okay, final thing. What if we're given graphs? Okay? What if I'm given some function? I'm going to try really hard. Ooh, I don't like that. I'm going to try really hard to draw this the way I want it to go. Okay, good. Hopefully you can see all of those points, okay? Everything on a graph basically can be written as coordinate pairs in function notation also. So let's start with this point. This point is 1, 4. It can be written in function notation f of 1 equals 4. So this is our coordinate written in function notation. The function, using 1 as the input, gives us an output of 4. This coordinate, 3, 1, can also be written in function notation. F of 3 equals 1. Okay? This coordinate, 4, 0, could be written in function notation. F of 4 equals 0. Notice all of them are in the format. F of x equals y. They're all in that. Put the x there, put the y there. Oh, hold on. Didn't I say originally that f of x and y are interchangeable, meaning they're equal to each other? This actually tells us f of x equals y. Woo! It's almost like I'm teaching something. Hopefully we're all learning it. Okay. This other point, 0, 2, can be written like this. F of 0 equals 2. Right, so these are all of our coordinates. This is me writing them in function notation. Pause it if you need to. I tried to color coordinate this. I don't know if you can see the colors that well on the board. Okay, now let me show you how questions will be phrased. Okay? Let me show you how questions will be phrased. They'll say, find f of 3. Here's what you need to do then. If it says find f of 3, you need to be smart enough to say, that means x equals 3. So we are looking for question mark y. Okay? So you're going to literally look on your graph, 1, 2, here is x equals 3. Right? There's x equals 3. And then you're going to ask yourself, well, what is the height for that coordinate? The height is 1. So the answer is 1. F of 3 equals 1. Which if you rewind this YouTube video a little bit, you'll see that f of 3 equals 1 was one of the function notation ways that I wrote that coordinate anyways. Okay? So I'll have you guys try this now. Find f of 0. Everybody do that real quick. Find f of 0. You should have written down the answer is 2. For each of these concepts, okay, this is the x value, and what it refers to, what we're looking for is the height. Okay, we're looking for the y value. If the x value is 0, the y value is right there at 2. That's how we're looking at that. Let's try one more. Not to be mistaken with this. That would not have been the right point. In fact, let me show you what would have been written then. It probably would have said, find x if f of x equals 0. That is how we would have found this point. Because now we're saying the height is 0, and we're looking for what x gives us a height of 0. Well, the x value of 4 gives us a height of 0. Okay? Find x if the x value, if f of x equals 0. Let's try another one like that. Find x if f of x equals 4. Okay? Well, this is our height. We're looking for the x that gives us that height of 4. Here's the height of 4. Here's the x value of 1. So our function notation answer, f of 1 equals 4. Okay. I know I'm cluttering this up a lot, but you can always go back and rewatch it. And when you rewatch it, I think that that'll make things a lot cleaner and easier. I'm going to show you the other way that we could pose this. We could say fill in the blanks. Okay, fill in the blank. F of something equals 1. And then we could also say f of 1 equals something. So I might say fill in those two blanks. See if you can do that. Okay, well right here, we're saying our height is 1. There's actually 2 answers we could have written. I just don't know what this one is. I haven't marked that coordinate. I don't know where exactly that is. But I do know this one, okay? I do know that the x value of 3 gives us that height of 1. And so that's that problem. And this other problem says f of 1 is something. So now we're looking for the height. I know, you guys get to pause this and rewatch this. You think you're tired? There's like 36 minutes into this video. I just did like a full day of teaching, and now I'm 36 minutes into a video that I'm prepping for you guys. My mind is fried. Anyways, we're looking for the height when the x is 1. We know the x is 1. We are looking for the height. So here is x is 1. I don't see where I am yet. Oh, there we are. That is the height of 4 when x is 1. And we actually just found that point previously. So guess what? This is today's class. I hope you enjoyed it. That's a long video. Good luck. Enjoy. Take notes. Solve this. I will not make an ed puzzle because this was so long.